Jeremy. Well, thanks for the introduction. It's a pleasure to have everybody here today. I'm going to talk through today, of course, some of the ongoing work that has taken place at the CSHub in the area of competition, looking at it at the paving sector, which is obviously a really interesting study. It's a unique market, which has made us really interested in this topic. And so I'll provide, I'd say, about 20-25 minutes or so of presentation of the motivation for this research, some of our analyses, results, and conclusions, and then we'll leave the remainder of today's time slot towards any questions that you may have.
And just as a reminder, for those of you who may or may not have seen at the beginning, if you do have questions, there's a function in the WebEx window in the upper right for Q&A. So just to try to minimize background noise, we have everyone muted, but you can type in questions up there at any time. And then Ann Yu, our communications coordinator, has set this up. We'll be keeping track of those. And then during that Q&A period, she'll be reading them off to Omar to answer them. So.
Okay, great. So jumping right into today's presentation, the real motivation for this work within the CSHub has been that we know that planning agencies, whether we're talking about local municipalities, state DOTs, what have you, are looking for ways to effectively maintain their infrastructure systems. What we know is that if we talk specifically about the roadway system, but I think we can more broadly say this for infrastructure, we know that there's a significant amount of maintenance that needs to be taken across the system, significant backlog of projects to really improve the system moving forward. And furthermore, agencies are searching for techniques, to be as efficient as possible within the constraints of their limited available resources. Now, the real motivation for this work is, as I said, when we talk about, how do we maintain our system moving forward, what we know is that while the construction needs continue to be significant, the available financial resources to actually maintain the system and keep it up at the performance levels that we would hope has actually decreased relative to the actual spending that is required. And so this has motivated, state planning agencies, DOTs, to begin looking for new mechanisms, new ways to be as efficient and as effective within their limited constrained budgets, whether it's been moving towards asset management-based principles, what have you, which is some of the other work that's been taking place at the CSHub. But one of the core areas that we've looked at has been in the area of competition, trying to understand its impact, its effect in this industry. And what makes the paving industry in particular such an interesting case study is that we can view it as really two types or two forms of competition that are taking place. We can view it as intra-industry competition, so we have many firms across the industry who are bidding across different projects who are capable of delivering that project with the same material, with a given material. And what we can also view is that there's some form of inter-industry competition, so there are firms that are capable of procuring and delivering a project, but doing so with a different material, a different way of delivering that project. So we have really two forms of competition that are taking place in this sector. And from our perspective, we've looked at both of these areas, but in particular, where I think there's been probably the most novel contribution academically has been more in the area of inter-industry competition. There has been previous work in the area of inter-industry competition, both within the paving sector as well as across other domains. So with that said, the real motivation for this work at looking at competition is it's really been demonstrated across different industries that there are several factors that influence the cost competitiveness of a new business, a new industry entering a market. Factors such as the bargaining power of the buyers, the sellers in that market, the threat of new entrants, and one of the key factors, and this goes back to Porter's 5 forces, which has been a principle for modeling these systems for quite a while now, is the threat of substitute products. That if we have a higher threat of substitute products within our market, there's an increased likelihood of switching our products in response to, say, price increases for those commodities, those current products that we're using across our system. as a very simple example of what we're talking about when we're discussing substitutes, so I could be delivering Coca-Cola as an example. Same product I'm trying to deliver, but there are two alternative services out there, ways of actually delivering that product to the consumer. I could be doing it via bottles, or I could be doing it via cans. And so we have a product or a service that is able to satisfy the need of our consumer, but we have another product that can also fulfill it. And what we know is, or what we would anticipate, right, is that these two markets, whether we're producing our product, Coca-Cola in this case, with bottles versus cans, they're interrelated with one another. So say, for example, prices of one of the ways we could provide our product, bottles, increases in price, we would expect that demand for that way of delivering that product might decrease, and we might see then an increase actually in the demand for the other product or way of delivering that system, cans instead of bottles. This is just a simplified way of demonstrating how we might anticipate that these material substitutes would influence, or would interact with one another across the market. So as I stated earlier, really the goal of this competition work and our study has been trying to characterize, so understand both whether or not it's significant, this inter-industry competition in the market, but then also try to characterize its potential impact or effect. We had access to a fairly significant, fairly large set of historical empirical data on the unit price of different construction activities. And we used that data to then analyze and try to understand one hypothesis, that if we increase the inter-industry competition in our market, our hypothesis going into this was that it would lead to lower unit prices. And so the goal of the study is trying to understand whether or not that holds true and what is the effect, or what's the absolute impact of that competition. Now, in terms of developing a modeling framework to be able to extract this inter-industry competition effect, what we implemented here is a series of panel data regression models. What I'm saying here is that we have multidimensional data, so we have data available across time, but what we also have is information regarding not just the unit price of a given project, the quantity of materials that are going into it, where it was geographically located, what have you. So we have a lot of information, multidimensional, spread out over time. And in order to extract this inter-industry competition effect, what we really need to do in our modeling framework is have ways to account for the heterogeneity that exists in our data. And that is a function of time. So for example, as a very simple example, what we see oftentimes is that the prices of different commodities and services increase over time. So you can't compare, say, the unit price of a project in 2000 versus 2015. So having mechanisms to account for that. And then cross-sectionally, so oftentimes one key thing we see in this sector is there's an economies of scale. So oftentimes the unit price of a given project is a function of how large that project is. We need to be able to characterize and account for each one of these factors in order to then extract both the significance and the impact of this inter-industry competition effect I talked about. So in terms of the data set that was used in this analysis, what we used was historical empirical data that was collected by Oman bid tabs. And so one of the shortcomings and one of the things we'd like to work on moving forward, obviously, is to try to have actual versus bid construction cost data. But so what we did have was bid construction cost data for most highway works projects across the United States, looked at it most comprehensively over a 10-year window from 2005 to 2014. And then within that data set, we had data for just about every state across the United States, other than Hawaii, Alaska, and New Jersey. Now, for each one of the pay items, as well as the jobs that were in this data set, we had information regarding, say, the quantity of materials that were going into a project, as I said, project location, award date, the actual bid price on a project. As I said, this is multi-dimensional data that we have over time. Now, one of the things that we did was filter, screen, and remove certain data points within our original data set. For example, we removed certain pay items due to insight from some of our industry partners who are able to point out which pay items are most appropriate for what we're looking at. We also ignored, in this particular case, design-build projects. And then the last type of project our last, subsample of the data set that we had that we ignored was looking at small projects. And the reason for that is these projects tend to be highly variable. You can imagine that to complete a project, there's some component of fixed costs and there's some component of variable costs. When I have a low quantity of materials going in, the fixed costs tend to dominate. And so all of a sudden, external factors, whether I'm doing nighttime versus daytime construction, weather, what have you, leads to a lot of variability in the data. And so we just limited our data set to looking at some of the larger projects across the network. This left us with, I'd say, about 30,000 or so data points for the analysis. Now, the way that, as I said, we have a series of panel data regression models. And so this is the general structural form where the unit price, P, of the ith job in the year T is a function of a series of explanatory factors, X. And we also have an error term represented with epsilon here. Now, in terms of some of the explanatory factors that went into the model, so first is inter-industry competition. And there are multiple mechanisms or ways you might be able to explain it. One way we looked at it was looking at the percent of the state spending that was either going towards asphalt or concrete in that particular year. Another thing that we looked at, of course, was trying to understand the intra-industry competition. And so one way of looking at it is we have information for each project, how many bids were received. And so that was one way we tried to capture the amount of competition just for a given job, the intra-industry competition. We also, as I said, had to account for how our prices evolve over time, right? And so one way we've gone about that is we have some time fixed effects within our model that accounts for that price variation, price inflation over time. Also tried to look at factors such as project size. So these projects tend to have some economies of scale that explain some of the variability in the prices. Market size. Thought is that different markets might have different structures, and so that affects, again, the variability in our data set. Looking at just whether a job was solely in asphalt, solely in concrete, or some mix of the two. And then furthermore, what we did was look for each state, looked at, what was their policy regarding price adjustment clauses, historically speaking, trying to understand, right, those are a mechanism of passing on the risk from the contractor onto the agency, trying to, again, account for how that might be affecting the variability in our data. So we have all these factors going into our model, but ultimately what we were really interested in extracting was the inter-industry competition, and we have some of these other factors that I talked about here to explain the time varying and cross-sectional heterogeneity in the data. So then, having explained the general structure of the model, what we need to do is have a way of commenting on both significance as well as impact of what we're interested in this case, inter-industry competition. And so significance from a probability and statistics standpoint, we're trying to understand what is the probability that the factor that we're looking at has a non-trivial effect on our response variable being the unit price of a given job. So for each one of our parameter estimates that we'll generate, we have some probability density function of that coefficient estimate referred to as beta. And so we might have, this could be our estimate with the dashed line being what do we have as the expected coefficient value for beta, which is, again, the value that captures this inter-industry competition, and it has its own distribution on its estimate. We're operating with a sample and not looking at the full population. Now, what we can do is look at how far away our estimate is from zero. And if we have a very low probability that our null hypothesis going into the analysis is equal to zero, notice how very little of our probability density function crosses over zero, we would probably state that there's it's very probable that our estimate of beta is significant. On the other hand, we might have another parameter going into our model, and it has this distribution as well as this expected estimate, and you can see a fairly large portion of its distribution overlaps with 0, 0 representing basically that this parameter has a non-trivial or has a trivial effect on our system. And so in this particular case, we would probably say that there's a low probability that this beta and thus the significance of this particular variable is fairly low, and that we would probably want to drop it from the model. And then in terms of trying to understand impact, so we could have, for example, two variables, just factor A and factor B, and what is the distribution of its effect on the response variable? Again, in this case, unit prices. So both of these variables, we can assume factor A and factor B, they pass the first part of our test, whether they're significant or not. But we're also trying to understand is how large is their contribution to the variation in the data, how much should we really care about them. And so in this particular example, both factors are significant, but we can clearly see that factor B tends to have a larger impact on our response variable. And for our particular study, in order to understand the impact, we moved each one of these values between the 16th and 84th percentile. The reason for that is oftentimes, or one way to try to understand the relative importance of different variables is to estimate a standardized regression model, standardized coefficients. The underlying assumption of that, though, is that our variables going into the model are Gaussian or normally distributed. For many of the variables we had going into this analysis, that was not the case. But if you were to pull what was the equivalent of one standard deviation and its percentile on your distribution, you end up around 16th and 84th. So that was the reason for that particular selection. So jumping now into some of the results. The first plot here is just showing, what is our 5-year average spending on asphalt across the different material markets, ranging from as low as about 64% to up to 100%. And this is only looking at the most recent year. So looking at the average spending from 2009 to 2014. It gives just, a good sense of how each one of these states have a very different market in general when it comes to the presence of multiple materials in the market. Moving from that particular result, I just want to, step through when we talked about significance earlier, what were the variables, what were some of the important variables we found that were significant going into our model. And so first and foremost, what we found was, so in each one of these columns, the first column represents what were some of the significant factors going into the model. And then how does that affect the asphalt model that we had? And then how did that affect also the concrete model? And then a negative sign for each one of these variables is an increase in that factor is associated with a decrease in prices. So as a good example, so if we go to the first row and we look at asphalt jobs, we have a negative sign. So an increase in how we measured inter-industry competition. So increasing the inter-industry competition was tended to be associated or correlated with a decrease in unit prices for those particular jobs, and that also held true for the concrete jobs. Positive, on the other hand, is an increase in that factor is associated with an increase in prices. And so these were the factors that we found were significant, and these are their directionality. So inter-industry competition was one variable that was significant going into the model. Intra-industry competition, looking at, say, project size, and again, those economies of scale. So the more materials we have going into a project, the unit price of that project tends to go down, its market size, and we also, again, looked at, say, price adjustment clauses across a given state. Now, while this points to the significance of these different variables, we're unable to extract from this what is the impact or the effect, particularly of the inter-industry competition, which has really been what our conversation has been focused on. And so this plot here, again, shows you if you took the model in and of itself, you had every parameter set at its median 50th percentile value, and then one factor at a time, so say you started with the intra-industry competition, move that data between its 16th percentile, 84th percentile, and held all of the other factors constant, how did the response variable unit price change? The only one that wasn't moved between 16th and 84th was price adjustment causes, just because that's more of a binary choice. You either have it present in your system or you don't have it present in your system. So with that said, you can notice that some of the factors that seemed on the smaller side included the price adjustment causes. We see low variation. The bars are not very large, as well as intra-industry competition. If you go to, in the Asphalt model, though, the fourth row, so here we're looking at inter-industry competition, and the third row for the concrete model, you can see that it's, it has a non-trivial effect clearly on our system on the response variable prices that we're looking at. We're looking at, on this plot for asphalt, dollars per ton, while for the concrete model, dollars per cubic yard. And so translating this now, trying to maybe make this a bit more accessible, what is the implication of what we're saying here? So if we held all our other factors consistent, held them at their median value, and looked at what is the expected unit price of a bid if a state had first been starting at, say, 5% spending, and then each one of these values on the x-axis represents going from 5% concrete spending to 10%, 15%, 20%, all the way up to 40%. Again, remember I showed that the average 5-year spending across the state in terms of asphalt was no less than about 64% or so we stopped this at about 40%. If you went from 5% to each one of these values, just from how the model is structured, what would be the anticipated decrease in the unit price of your paving materials? And so if you started from, say, 5% to, say, 20%, you're looking at about an expected decrease for your typical project of somewhere on the order of about 7 to 8%. And this held true both across asphalt as well as concrete. So in terms of, trying to summarize some of the results, and obviously I'm happy to answer more questions moving forward, what we found was that inter-industry competition from the data we're looking at is strongly correlated with the unit price of materials, and it has both a significant as well as a fairly strong impact on unit prices. Now, one of the things that I haven't talked about here, and I think this is one of the areas we're going to potentially go moving forward, is trying to understand, yes, the data shows that these two entities or these two mechanisms are correlated with one another. If I increase inter-industry competition, it affects prices. But we don't really have a strong understanding of the mechanism. So we have a strong sense of the correlation between these variables, but we still need to do a bit more digging, a bit more work into trying to understand the causation in our models. So trying to summarize everything that I just talked about. So, we've developed a series of panel data regression models, trying to understand how significant and impactful is inter-industry competition, trying to account for, in the panel data regression models, the heterogeneity that exists in our data, either across time or just within a given year in and of itself. The findings suggest, as I stated, that increasing inter-industry competition, which was our hypothesis going into the analysis, would potentially be an effective mechanism for agencies to reduce their prices, reduce expected bids that they would receive for given projects that they're procuring, and that seems to be the case from the data that we were looking at. And like I said earlier, I think that one of the future areas we're really interested in is moving beyond now just the correlation, but trying to understand the mechanisms really in place in the market that lead to this reduction in prices that we're seeing in the data that we're looking at. So with that said, I think we'll now open it up to any questions, and I'll be happy to answer any questions that anyone may have.
Thanks so much, Omar. I really appreciate it. So as we mentioned at the beginning, there's a Q&A button in the upper right of your WebEx screen. If you have questions, please go ahead and type them in there, and then Ann will be collecting them and sharing them with us. Do we have any?
Thanks, Jeremy. Thanks so much. Yeah, I just wanted to note one more thing, too, which is that we do have a summary of this information on our website as well. If you visit the CSHub website, which is displayed there on the screen, and the resources section, there's a summary called Measuring the Impact of Competition. So that is available too. And our first question is, first to say good results, and the question is there a tipping point? That is, can an agency just bid on a project and then see these types of results? What does an agency need to do to get these results?
The analogy I like to use is kind of like you hear a lot about different health-related studies, and the first step that often happens in these health-related studies is that they take a lot of data and then they try to find correlations like this, right? They find what are people's eating habits or their patterns, and then what type of health outcomes do they have, right? So they might be able to establish that there's a correlation, but then between higher risk of heart attack and eating fatty foods or something like that, right? So that's the first correlation that you do. Then the next step you do is you try and establish a bit more of what's the mechanism behind that, and then you can do some controlled experiments, right? So we're at a similar spot right here where we can look at a bunch of this data and say that there's a correlation, but we don't, we maybe have some theories on what we can do, but we don't have the research to support specific steps. I think having said that, you know, if we take some cues from the Michael Porter's 5 forces model that Omar presented at the beginning, you know, that there clearly are at least some steps that can be taken to at least evaluate the competition of material substitutes. And then what would be interesting is then to be able to track whether those have any impact. And I think the thing that needs to happen, though, is it has to happen over several years, and you know, it's kind of a long-term process, because just like Omar showed, we are looking at 10 years worth of data for a reason, right? Because sometimes there's significant fluctuations in projects one way or the other, particularly in smaller markets. So I think that's a long-winded way to say we don't have research yet to support specifically which actions should be taken. But I think that what we'd like to see is that this type of theory tested out in different markets to see whether it does indeed, you know, whether we can then identify a specific mechanism.
Thank you. Excuse me. The next question is, does competition have to be something like alternate design, alternate bid, or can competition simply be introducing more alternate materials, in this case, concrete?
Yeah, so I think this study seems to, at least our results suggest that introducing different, what we refer to as material substitutes, but they're just an alternative way of providing a service, in this case the roadway, that it's one, from the data in and of itself, it suggests that if you do that, it tends to be associated with reduced prices. But a similar token, right, there are obviously many other ways to induce further competition in the market. Obviously, looking at alternate design, alternate bid is one example. So this isn't to say that, you know, this is maybe better than alternate design, alternate bid, but there's a suite of options available to a given DOT, and this is one way that they could go about doing so.
But it could be alternate design, alternate bid. It could just be choosing to do a suite of different, you know, paving projects. I think there's a couple different ways that it could be done, and so we're not prescribing one thing in particular.
Great, thank you. We've just received those 2 questions so far, but if anyone else does have questions, please feel free to ask them via the Q&A function.
Sure. Yeah.
Hang out for another minute.
Yeah. We'll definitely.
Yeah.
While we're doing that, we can go back to that, the one slide on the 5 forces, to talk a little bit about that. You know, as we said, there are many things that can affect this rivalry among existing competitors, and as Omar said, it's this thread of substitute products or services that can affect the marketplace, but that doesn't necessarily prescribe then what's a particular way to accomplish that. And so I think we realize that's going to be different in different paving markets depending on how they're set up, and so that's what we think there can be different solutions for different markets.